a bearing gets pressed into each end.
Okay.
The ID is not perfectly round. It's a very clean, welded tube. You can almost not feel the seam in there. It's very good, but it's not perfect.
Okay.
I put a piece of steel in here and I cut it on a 1.5 degree taper so that it locks in here.
Okay.
And then I put a live center in the other end and I tighten it until it's locked up on here and I can't turn this.
Yes.
Normally, what people do is they have a live center here and they'll put another center here and they'll get something that looks like this that is called a lathe dog.
Oh.
DOG, just like whoop, whoop, okay?
Okay.
All right, this goes in here, and what happens is you tighten it to the shaft, and as the chuck comes around, it pushes this and it turns.
Oh.
Okay?
Okay.
So there's no need for a plug like that, and it's very accurate.
Okay.
But then you have to turn it around the other way and do the same thing again.
Mm-hmm.
In this case, I need a seamless uniform all the way across.
Okay.
So I'm not using a dog and a dead center
Okay.
with a live center.
Okay.
Now, I'm using carbide. With carbide, the speed you want to turn is anywhere from 75 to 150 feet per minute.
Mm-hmm.
I picked the speed that I think is pretty good. Just to give it a shot, I'm going to take a light cut. Now, this is what I'm going to use to tell me where I am.
Uh-huh.
Each one of these calibrations is 1,000th of an inch. Most lathe manufacturers, if you go from 0 to 10, or if you go from 20 to 0, let's go that way. If you go to 0 to 20, that's 20 thousandths of an inch that you go in, which means you have reduced it by double that, 40 thousandths.
Oh.
LeBlanc doesn't do that.
Okay.
LeBlanc says if you move 20 thousandths, you remove 20 thousandths.
Okay.
There are a few differences that I explained previously about a LeBlanc.
Okay.
Let's see what we have. Now, I'm just going to take a very light cut. I'm going to see where I am. I'm going to take 10, 15 thousandths. And let's see what happens. When you're using carbide, if you get extremely shiny, that usually means you're going too fast.
Okay.
But in this case, I'm machining stainless steel,
Okay.
so it probably will be very shiny.
Okay. Yeah, it is shiny. Very shiny.
Now, to save money,
Uh-huh.
I want to go across as quickly as possible.
Uh-huh.
And right now, this looks like a good speed. There's a clock up there. I should have started, but it's not going to take that long.
Ah, you don't have to operate now.
Now the machine does it for me,
Yeah.
but I am responsible to measure.
Yes.
Now, hopefully, it locked up on that taper. If I try to take a heavy cut, that taper is going to let it slip. Now, this is only 15 thousandths on the diameter, which means I only went in 7.5, but that was over there.
Okay.
Because it wobbles, some areas I'm taking off more, some
Oh.
areas I'm taking off less.
Okay.
Now sometimes, you see this screw here?
Uh-huh.
Sometimes you get a taper. It's big at one end, small at the other end. That's what this is for. There's a nut just like this on the other side.
Uh-huh.
You loosen and tighten and move it this way and that way.
Adjustment.
But every time I use this lathe, I make fine adjustments. And I don't think an adjustment will be necessary.
Uh-huh.
We're going to find out. I'm at 335. Take a look on the left. Now another thing is heat.
Uh-huh. It's hot now?
Slightly warm. Not really warm, but a little bit. I can hold my hand on it all day long. It's probably about 90 degrees.
Uh-huh.
It's warm to the touch, not hot.
Okay.
Now I'm going to measure it and see where I am.
Okay.